Good morning, students. Welcome to Bindu Dhadwal Chemistry Lessons. We are doing chapter Hydrocarbons, and today's topic is conformations of ethane or alkanes in general. So, in alkanes, the carbon-carbon single bond is the sigma bond, and free rotation about this is possible. The electron distribution of the sigma molecular orbital is such that it will not be disturbed due to rotation about its axis. For example, if this is one carbon with 3 hydrogens attached to it of the ethane molecule, and this is the other carbon, so even if this bond is rotated, these distributions are not affected. These electrons, they are not affected. There is no hindrance in the rotation of this bond. So this permits free rotation about the carbon-carbon single bond. And rotation results into different spatial arrangements of atom in space which can change into one another. For example, this is first carbon and the second carbon. This conformation is such that the hydrogen of the second carbon hides exactly behind the hydrogen of first carbon. So this is an eclipsed conformation. Similarly, all the hydrogens are eclipsed by the hydrogens of the first carbon. This is one conformation. We can rotate this bond like this to arrive at other conformations. So the two extreme conformations are one eclipsed conformation and other staggered conformation, in which the hydrogen of the second carbon atom can be seen from the first carbon atom itself. So these in this conformation, the distance between the two hydrogens is the maximum. There is minimum repulsion and the distance is maximum. This kind of conformation is called staggered conformation. So one is eclipsed conformation, other is staggered conformation. So once again, this rotation results into different spatial arrangements of atoms in space which can change into one another. Such spatial arrangements of atoms which can be converted into one another by rotation around the carbon-carbon single bond are called conformations or conformers or rotamers. The alkanes can have infinite conformations. By rotation, you can see that they are having infinite conformations by rotation around this single bond. However, it may be remembered that rotation around a single bond is not completely free. It is hindered by a small energy barrier of 1 to 20 kilojoules per mole due to weak repulsive interaction between the adjacent bonds. Such a type of repulsive interaction is called torsional strain. Even though rotation is almost free, energy required is very less, but still these bonds will cause a little bit of repulsion, and hence a torsional strain will develop. Conformations of ethane. We have said that there are infinite possibilities, but two extreme cases of conformation are eclipsed conformation and staggered conformation. In eclipsed conformation, it is the conformation in which hydrogen atoms attached to the two carbon atoms are as closed together as possible, and this conformation is called eclipsed conformation. On the other hand, in the staggered conformation, the hydrogen atoms of the two carbons are as far apart as possible and are known as staggered conformation. Any other intermediate conformation is called a skew conformation. It may be remembered that in all the conformations, the bond angles and the bond lengths remain the same. These eclipsed and staggered conformations can be represented by two types of projections. One is Sawhorse projection and the other one is Newman projection. In the Sawhorse projection, the molecule is viewed along the molecular axis. So it is then projected on paper by drawing the central carbon-carbon bond as a somewhat longer straight line. Upper end of the line is slightly tilted towards the right. The front carbon is shown at the lower end of the line, while the rear carbon is shown at the upper end. The lines are inclined at an angle of 120 degree to each other. Sawhorse projections of eclipsed and staggered conformations are depicted here. Newman projections. In these projections, the molecule is viewed at the carbon-carbon bond head-on. The carbon atom nearer to the eye is represented by a point. 3 hydrogens attached to the front carbon atoms are shown by 3 lines drawn at an angle of 120 degrees to each other. The rear carbon atom away from the eye, is represented with a circle, and the 3 hydrogen atoms are shown by shorter lines drawn at an angle of 120 degrees to each other, projecting from the circles. So the Newman projections, this is the eclipsed projection where the hydrogen of the rear carbon atom is hidden by the front hydrogen of the front carbon atom. This is the eclipsed conformation, and the other one is the staggered conformation where hydrogen of rear carbon atom can be seen clearly even from the front. So the conformations can be represented by Sawhorse projection and Newman projection. Relative stability of conformations. In the staggered form of ethane, the electron clouds are as far apart as possible. Thus, there are minimum repulsive forces, there is minimum energy, and there is maximum stability of the molecules. So staggered forms are more stable conformations than the eclipsed forms. On the other hand, when the staggered form changes into the eclipsed form, the electron clouds of the carbon-hydrogen bonds come closer to each other, resulting in increase in the electron cloud repulsions. To check the increased repulsive forces, the molecule will have to possess more energy, and because of it, it will have lesser stability. So the eclipsed conformation has increased repulsive forces, more energy, and hence lesser stability. The repulsive interactions between the electron cloud which affect the stability of conformation is called torsional strain. Magnitude of torsional strain depends upon the angle of rotation about the carbon-carbon bonds. This angle is called dihedral angle or torsional angle. So this angle between hydrogen of one carbon and hydrogen of other carbon is called dihedral angle or torsional angle. Of all conformations of ethane, the staggered form has the least torsional strain and the eclipsed form has the maximum torsional strain. The staggered form is more stable than the eclipsed form. Hence, molecule largely remains in the staggered conformation, and this conformation is the preferred conformation. Thus, it may be inferred that rotation about carbon-carbon bond in ethane is not completely free. The energy difference between the two extreme forms, that is the staggered and eclipsed, is of the order of 12.5 kilojoules per mole. It is small, so even at ordinary temperature, the ethane molecule can gain thermal or kinetic energy sufficient enough to overcome this small energy barrier of 12.5 kilojoules per mole through intermolecular collisions. So rotation is almost free about the carbon-carbon single bond in ethane. But it has not been possible to separate and isolate the two different conformational isomers of ethane. That's all about conformations of alkanes. If you like the video, please do share and subscribe. Thank you. Have a nice day.